Hi group, it's Mrs. Schaus here. We were talking about graphing functions in our last video, and we hadn't yet explored the use of our calculator as a way to consider some graphs. So I'm going to use the TI-84 as demonstration. I think that's the calculator that the majority of you are using. At some point, I'm going to reference this other calculator here, which is a TI-83. And some of you might have other calculators like the TI Inspire, or maybe you have a different make of calculator like a Casio or something like that. My instructions will be primarily geared towards this TI-84. All right, so first of all, some important keys for you folks to be aware of when you're trying to, graph with your graphing calculator. I'm going to turn this on first of all. Oops, I'd like to get rid of that. And I'm going to hit this y equals key. Now that is the key where, I'll clear this, that is the key where you would now type in the equation or description of the particular function that you'd like to graph. So I'm going to start with this simple one, y equals 2x minus 7. And so I know you can't quite see. Let me pull this back a little bit here so you can see more of the calculator. I want to type in 2, just, the number 2 down here at the bottom. So 2. Now where do I get the variable from? The variable key is right here below the mode key. And it does have a variety of variables, x, t, theta, and n, and that depends on the mode that your calculator is in. We should all be in function mode right now. So when you hit that, you should see an x come up. If you get a different variable besides an x, you should see me in class and I'll help you change that mode real quickly. Or maybe you could even Google it, up to you. So I'm going to type in that 2x and then minus 7. I'm going to hit the enter key down here to store it. Now, if I wanted to put in more than one function at a time, I could come down now and put in some, subsequent ones. But I'm not going to do that. I just want to look at this one equation, y equals 2x minus 7, and see what its graph looks like. So again, after I hit the y equals, type in the equation using this variable key, enter to store it. Then I'm going to hit this key in the upper right corner that says graph, and that will show me a graph of the equation. Now, sometimes you won't see anything. Keep in mind that this is just a small portion of the coordinate plane. The plane is infinite. It keeps expanding out in all directions, right? So you can envision that if this line were actually something that were plotted up here, we wouldn't see it because it would be off of the portion of the coordinate plane that we were looking at. So we do have to think a little bit about maybe some input-output for the particular function to try to decide if we're looking at a reasonable or appropriate part of the plane. We can also adjust the piece of the plane that we look at by hitting this window key. So underneath the window, it allows me to pick the minimum and maximum values that I like for the x. How high would I like, well, it starts with minimum, so how low would I like this graph to go in an x sense, and how high in an x sense. And then it also does the same thing down here for the y minimum and maximum values, how low or how high would I like those values to be. The scale of 1 simply means that they're going to make a tick mark at each 1 unit interval. You could change up those intervals if you want to, but I primarily tend to just keep them at 1. Okay, a standard window would be for the minimum values to be -10 and the maximum values to be +10. You can change the window to be anything you want just by physically typing in the number. Now for the minimum, when I say -10 here, keep in mind that this is a subtraction key. You can't use that. You've got to use this one for a negative number. So I hit that and then I would say -10 and hit enter and it'll store it in there. And now I'm going to hit +10 and store it in there. So you can make any changes that you'd like to look at a portion of the graph, and you'll see that when you do that, it does change up the piece that you're looking at. So this looks a little different than it did a moment ago. I still don't have it on the standard window. If I hit that again, I notice that my y's are going between -12 and +14. I could go down and change those, but there are also some ways that we can change our window maybe a little bit more simplistically. So if you hit zoom, underneath zoom, the options that I want you to consider for now are zoom square. That means that because physically this is longer than it is tall, it sets a scale along here and here so that what you're seeing truly looks squared up. Now that's not important right now, but later on when we're doing things like graphing circles, if you put in the equation for a circle and you don't have your window squared up, it might actually look like an oval or an ellipse, even when it's really not. So that would be one you'd use at some point, not now. Here's that Z standard or zoom standard. If I hit that, it automatically changes my window to now be the 10 by 10 that we talked about before. So again, if I look here now underneath window, notice that the Y min and max are also at negative and positive 10 respectively. All right, I'm going to go back to the zoom. So I said the ones we were going to focus on, zoom square, not today, but in the future. Zoom standard, which is our sort of typical one. And then there is one down here, zoom fit, that sometimes will give you a fit for the graph if it's something kind of unusual and you're having struggles in trying to find the particular window that will work. So sometimes that'll be of a little bit of assistance as well. All right, let me just go ahead and clear that. And we're going to leave our window at the negative 10 to 10 for both the X and the Y. This next one that I want to put in, what's different about it, is that it is quadratic. So I'll still hit Y equals. I want to clear this out, so I'm just going to hit clear, and I'll type in my new equation. Remember that the X button is here below mode. There is a squared key right here, but for any powering, whether I wanted to raise it to a third power or an eighth power, or whatever power I want, I can just use this little caret key and then hit the number. So if I wanted to hit caret 2, that would raise it to the second power, or I could simply use this squared key in that case. And I'll just type in the rest. Plus 2x minus 15. Remember to hit the enter button down here to store it. And then once it's stored, all I have to do is hit graph, assuming that I've selected a reasonable piece of the graph. Well, that is reasonable. I do see this sort of parabola shape going on, but if I wanted some information about where that vertex is located, I would need to look down a little further. Well, if I'm wanting to look down further, what is it that I want to change in the window? I mean, do I need a smaller X value? If X's get smaller as we work to the left, what I really need is a smaller Y value. So I'm going to go here, and for that Y minimum, instead of negative 10, what if we put in negative 15 or negative 20 or something like that, that helps us to see that value down below. That seems reasonable right there. So sometimes we just have to play with our graphs, the window a little bit to be able to fully see the information that we're trying to find. Okay, I'm going to clear this one. So again, I'm going to go back into Y equals, hit clear to get rid of that, and I'll move on to the next one. So I intentionally put these next few in here because I want you to know where you can find the features with a Calculog that try that again. The features or catalog items within the calculator that will allow you to do things like graph an absolute value or graph a greatest integer function. Okay, so underneath the math menu right here, right below the alpha key, it says math. There are some different menus under here, and different parts of them we'll explore at different times. But for now, the ones that I want you to consider are, well, first of all, numbers 4 and 5. There's a cube root and an X root. The X root means that you could take a 5th root or a 7th root or an 8th root, any index root that you want to. So that's kind of an important key for us to consider at some point. If I use my right arrow key to come over to the second menu, it has these next couple of items that I'd like us to look at. ABS stands for absolute value. That's the one we're going to do right here. And if I work my way downward, number 5, INT, stands for integer. That's the greatest integer function. So we'll use that one in a minute. Let's go ahead and hit enter because we do want an absolute value graph next right here. And this was actually one that was in your packet that we had considered before. We made a table of values to graph this. So now let's go ahead and put in X plus 3. And I'm going to use my right arrow key to come out of that. If I had some additional operation outside of the absolute value, this is where I would continue onward with that. I would have just used that arrow key to go from the interior of the absolute value to the exterior. That's all I have, so I'm going to hit enter to store it, and I'm going to hit graph. If you hit enter an additional time, it will also graph it in addition to graphing based on just hitting this graph key as well. All right, that's a nice looking absolute value graph. It looks similar to what we did by hand. We noticed that it does have its vertex here at -3, 0. Maybe not the best screen for that particular graph, so maybe I would like to go back and change this now to a -10. That's a little better, but again, maybe I would even want to change this window up a little so that I'm looking just more at this particular area. Up to you. Okay, let me clear that. Go back in and clear that graph and type in my next one. Remember that I said if you hit this key below alpha, the math key, and go over to number, the fifth item down says int for greatest integer function. And it doesn't give us the symbols, it does just give us a parenthesis, but what this means is, what is it that you'd like to take the greatest integer, function of? What is the input going to look like? And so x plus 1 is what I'm putting in there. And again, I'll enter it and hit graph. Now, when I do that, I get these little stair step pieces that we're used to seeing. And, yes, I could probably zoom in and look at a smaller piece of the graph. In fact, let me just go ahead and do that. I'm going to change this maybe to like -5 to 5 for both the x's and the y's. There we go. Makes our steps look a little bit easier to see. But there's some important things to notice. First of all, notice that I can't see the hollow dot that sits on the right-hand side. So, and there's a piece right here on the x-axis that you sort of can't really see either because it's just sitting right on top of it. So it's your job to be, just thoughtful, or, kind of using your own intuition about how these functions are operating to fill in the gaps of what the calculator is not able to do. It's not able to indicate to you that there's a piece here that's overlapping with the axis. It's not able to indicate to you those open or hollow dots. Okay? All right, I want to switch for just a moment and take a look at the TI-83. So for the TI-83, I graphed the same function here, the greatest integer of x plus 1. And I'm going to hit graph. Oh my, what's going on here? Well, let me change up the window again so that we are looking a little bit closer. Okay, so keep in mind this is an older calculator. In a drawing sense, it wasn't sort of able to, I'm going to call it pick up the pen. So it drew apart. Electronically it went, oh, I need to be up here. Drew the next step. Oh, electronically it said I need to be up here. Drew the next step. So it kind of is drawing in the back side of the steps. But again, they're not really part of the absolute value graph. So this device can be a good tool for graphing, but it's not perfect. You have to have understanding about how these different families of functions are working. Okay? Otherwise, you might be misled. If you put something like this down on an assessment, you understand that I can't give you credit for that as a graph. First of all, this wouldn't even really be a function because the back side of these steps are vertical pieces, and so it would fail the vertical line test. All right, I'm going to get rid of this 83 for the moment and come back to my 84. And the reason I put another greatest integer function here isn't just to continue to demonstrate the graphing piece, but something about these greatest integer functions. So let me go ahead and head back here. I'm going to clear that, and we'll type in under math, over to number, and down to integer. I want to put in 1/3, so I'm going to do like 1 divided by 3, right? That's the same thing as a third, times x plus 2, and I'll close that parenthesis. I'm going to hit enter to save it, and then hit graph. And now I'm seeing my stair steps here, but what kind of happened? Maybe I need to actually, in this case, zoom out a little bit. And what ends up happening is that I discover I've got very, I'm going to call them wide steps. Remember that we talked about the different pieces of the domain that we were going to look at when we were making a table of values being equivalent to the reciprocal of the coefficient. So if I take the reciprocal of 1/3, I get 3. So notice that the width of these steps is 3 units long rather than 1 unit long like we saw up here in the previous example. So I just wanted to take a moment to demonstrate that while we were looking at our graphing calculator usage. There's much more we're going to learn about the graphing calculator, but hopefully this is at least an introduction for those folks who haven't worked with some. I know some of you are very proficient with them, and some of you this is the first time. Good luck in working with them, folks. Feel free to ask questions as they come up, and I'll talk to you soon.